Morning, ladies and gentlemen. My name is Cathal and as Chair of the RDS Foundation Board and Co-Director of the research programme presented here today, I'd like to welcome you. On behalf of the RDS and the programme, it's my great pleasure to welcome you to today's joint WaterMARKE RDS Water Quality webinar as part of the RDS Climate-Smart Agriculture Series. WaterMARKE is a project undertaken by Teagasc and the University of Galway to understand some of the economic and behavioural drivers of water quality. It is funded by the Environmental Protection Agency and the Department of Agriculture, Food and Marine. WaterMARKE, or Mitigating Agricultural Impacts Through Research and Knowledge Exchange, is a multidisciplinary project. It connects the areas of biophysical science, socioeconomics, behavioural psychology, and implementation science to understand drivers of water quality and related behaviours on farms. Improving the environmental footprint of farms and food production is a major goal of public policy. Water quality presents particular problems incorporating complexity in three dimensions: on-farm activity and other human activity, local weather and climate conditions, and local hydrological conditions, all of which impact water quality. It's been an area of significant policy focus through agri-environmental schemes, regulations such as the Nitrate and Water Framework Directives, as well as significant investments in research and extension, including programs such as ASAP and LOCLO. Farmers have engaged significantly in water quality improvement with important practice changes over the last 20 years or so. And while there have been improvements until 2015 in water quality, we've seen a reversal in recent years as the economy recovered from the financial crisis and as animal numbers increased after the abolition of milk quota. We now face the challenge of maintaining existing gains and pressing on with improved practices to continue to improve farm level practices and to deliver on ambitious goals of the Water Framework Directive. While there have been many technical solutions developed and proposed by physical scientists, the challenge is to ensure practice adoption and to deliver on the potential proposed measures to improve water quality. In this webinar, we hear from a variety of economists, specialists, and behaviour scientists on the economic and behavioural issues associated with water quality improvement. The webinar comprises two segments, with a focus initially on the spatial context of water quality mitigation, behavioural drivers of water quality measures, the economics of on-farm implementations. In the second session, we will hear about the characteristics and complexity of on-farm mitigation measures, psychological drivers of engagement by farm advisors, a unique system-wide perspective in relation to delivering change. And both sessions will be followed by discussion with a panel of experts. We are grateful for the participation of a number of expert analysts from outside the project who will provide insights and comments on the work undertaken. This webinar is organised as part of the continuing RDS Climate-Smart Agriculture Series, where we address the factors influencing the sustainable economic, environment and social development of agriculture in Ireland. And I look forward to the presentations and to the discussion afterwards. On behalf of the Society, I want to thank all of those involved in today's webinar for taking time out of their busy schedules to be with us here today to share their insights and expertise. I'd especially like to thank our partners in today's workshop, Teagasc and the University of Galway, and to thank them for their help and support in organising this important and timely discussion. I would like also to express my appreciation to Prof. Ian Coy, and Mary Ryan, the members of the Committee of Agricultural Affairs, for the work in organising today's event. So I'm also the chair for the session, and our first opening remarks will be by Professor Frank O'Mara, the Director of Teagasc, who will give an introduction to today's webinar.
Good morning. Frank O'Mara is my name and I'm Director of Teagasc, and I'm delighted to welcome you to this seminar on the WaterMARKE project, and thanks to Mary Ryan, my colleague, for giving me the opportunity to do so. Water quality is a very important issue for all of us, and in particular for the agriculture community. There's a lot of effort going on to improve water quality to ensure compliance with the Water Framework Directive, both here in Ireland and right across the European community. And no doubt we have significant challenges in relation to that, particularly in the agriculture sector. So one of the fundamental issues in relation to water quality is the difference that soil type and topography and farming system can have in relation to the impact of agriculture on water quality. And that brings us to the need to have local information, whether it is on the farming practices and the farming system, or the soil type, or the topography of a particular region. And that's where the WaterMARKE project focused on. Here in Ireland, one of the responses to this spatial impact is the ASSEP programme, which Teagasc runs in conjunction with LawPro and the dairy co-ops. And here we want to get down to an individual farm level and give advice to individual farmers as to what they can do on their farm to improve water quality. So no doubt you're going to discuss issues like that today at the seminar, and I hope you have a very good and informative day, and that there are lots of lessons learned and takeaway messages from the day. So thank you very much.
I'd now like to hand you over to Professor Mary Ryan of Teagasc, who's the coordinator of the project, to give an overview of the project. Thanks,
Cathal. Some slides coming up there now. Essentially, you've heard from both Cathal and Frank that water quality and improving water quality is a complex problem. The science itself, to start off with, is extremely complex. This project, as you can see, WaterMARKE has a large number of participants, and we're kind of coming to a close with the project now at this stage. What we want to emphasize is we want to bring out some of the main messages, and also emphasize the complexity, and also to remind ourselves that it's human activity that causes pressure on water quality by and large, and that human activity involves all of us. Every time any of us has a shower, runs a washing machine, a dishwasher, flushes a toilet, we're all contributing to things getting into the water supply that shouldn't get there. The impact varies hugely. You've heard both Frank and Cathal say it in terms of location and the soils and geology, in terms of the level of risk and maybe the speed or rate of decline of water quality in particular water bodies, but also very much on farm management practices. And the problem about water quality is that, unlike greenhouse gas impacts, you can have different levels of agricultural activity that can have greater or lesser impacts on water quality in different local contexts and with different farm practices. So our problem here is trying to figure out, there's a huge knowledge level required for dealing with water quality. And it needs to be the farmers need to be able to understand, have a much better awareness of the problem, but also understand how to mitigate it. And in 2017, the EPA had come together and decided that there were lots of projects out there looking at the technical and scientific aspects of water quality, and what they wanted to do in their call that we responded to was to actually focus on the knowledge exchange and the awareness and the development and the uptake of measures, and to figure out how do we kind of simplify that complexity to get some more uptake. So essentially we focused on those areas, and you'll hear 6 presentations today focusing variously on spatial aspects, how to localize models, the cost effectiveness and how it might vary in spatial areas, and in terms of what are the characteristics of win-win measures. Can we use those to get more adoption of win-win measures? And then you will also hear about, we were very lucky, ASSEP hadn't started at the beginning of this project, but we were able to work very closely with the ASSEP team, who have developed a very rich and informative database, and we were lucky to be able to work with them. And also with behavioural psychologists in University of Galway, and pulling kind of the whole project together. We took an innovation system perspective that I'll speak to you about at the end of towards the end of the seminar, and that should hopefully bring things together and draw out our conclusions from the project. I'll hand you back over to Cathal now for the next session. Thank you very much.
Okay. We now can start our first section. It's supposed to economics and spatial issues. And the first speaker is a postdoc on the program, Dr. Yuting Men, who works for Teagasc, and will be looking at 2020 water quality analysis.
Hi, good morning, everyone. I'm very glad to introduce my work. Okay. Can you show the PPT? Yeah, thank you. Yeah, the spatial relationship between water quality status and agricultural activities. The methodology develops as follows. We start from national model, then go to the regional model. Then finally, we have the local model. We want to increase the spatial resolution and provide more local information at each stage. First, we look at the best water quality, the high status over time. We see considerable mobility where the monitoring sites enter and exist high status. However, there is a higher share of sites that exist high status. It is a big concern because the high status river qualities are the reference sites for the other water qualities. So next stage, we will see the regional model to see the variation in the location of the water bodies existing and entering high status. We see the drivers of mobility also vary across regions. The significant drivers are agriculture, population, septic tanks. This map shows the water status in 2018 at water body scale. We can see the blue areas are the high water status, were associated with less rural activity and the lower population. The red areas are the bad water quality status, were associated with high population density and estuaries. There are considerable local variations. This map shows the spatial distribution of agricultural phosphorus in 2018 at water body scale. The data is provided by EPA SLAM model. We can see the heavier the phosphorus loads located in the northeast and the southwest areas. We want to see the relationship between water quality and the SLAM agricultural phosphorus. Then we need local models to examine it. This map shows the local relationship between agricultural phosphorus and the water status. We can see the local relationship vary spatially. Some strong negative relationship areas coincide with critical phosphorus sources areas. And there are other drivers dominant in white non-significant areas, which need further research. We put more other drivers into the model to see the impact of the increase in population density. We can see the map, the population density increases from 2011 to 2020 in the most of the country. And the livestock density also increases from 2010 to 2020 in the most across the country. And the water quality changes from 2010 to 2020, and considerable fluctuation, but general decline in many areas. Yeah, we also do the decomposition of the changes using the national model. We can see the 1990 to 2000, this period of time, the water quality worsened, the environmental impact of a farm worsened, and the farm activity intensified. Observed non-farm activities worsened. And during 2000 to 2010, the water quality improved and the environment impact of a farm improved considerably. Farm activity intensified. Observed non-farm activity changed marginally. From 2010 to 2020, the water quality worsened slightly. environmental impact of a farm more or less the same. The farm activity intensified, observed non-farm activities changed marginally. And finally, the environmental efficiency gains made in the earlier period of time have been maintained, but the increase in animal numbers have put pressure on water quality. Next step will be to undertake this the composition of drivers using local models. Thank you.
Thanks, Yuting. And I get some take-home points from Yuting's presentation. They want the local variation, how there's very significant environmental and agricultural variation across the country, which I guess creates a challenge in finding solutions. We don't necessarily require the same solutions in different places, and that's very difficult to do. I guess overall trend, there's been worsening water quality up to early 2000s, then there's been an improvement, we're falling back a bit, and that there have been also improved environmental impact due to on-farm measures, but we see a reversal of the total impact of agriculture in the last few years with the rise in numbers. So to take a deeper angle on implementation of measures, I'm going to introduce Daniel Urban, who's a PhD student at the University of Galway, working on the project. He's funded by Teagasc as a Welsh scholar and co-funded by the Scottish Rural College in Daniel House.
Thank you very much. Good morning, everybody. Today, during this brief presentation, I will be talking about work on a novel agri-environmental modeling technique. And we are essentially looking at what farmers can do to address their excess nitrogen loads, what is the cost efficiency of that, and what role does geography play in all of this. Excuse me, could you help me with moving the slides? Thank you. So to give a little bit of a background information, as Yuting has already shown, the impact of humans on agriculture in specific is highly localized. So if we want to design measures or design analytical tools that we are using while designing policy, we need to take these specific local conditions into consideration. Also, the reason why there is quite a large variety in terms of the impacts, it has to do with the structure of farming in the local areas themselves. So that's the focus that we need to take. We are looking specifically at river subcatchments. This analysis that I have undertaken here is looking at nitrogen loads. So that's a long way from the actual environmental impact or water quality, but nitrogen loads, they act as a proxy, as one of the factors of the economic activity that can be used as one of the representations. Next, please. So the questions we're trying to answer here, since we know that there is this kind of spatial variation, how will the costs of the individual measures that farmers can apply be spatially distributed? And why is that? Since we're assuming there is going to be some kind of systemic variation, what are the drivers of that? And how can we use that in designing policy or support measures? Next, please. This model is a farm level modeling system. So instead of some kind of an aggregate system, we're looking at each farm specifically. And each farm in this model can choose from a program of 12 measures that are aimed at reduction of nitrogen loads. The main variable we're focusing on is the marginal abatement cost, or cost per unit abated. Essentially, we're asking how much would it cost each farm to reduce their nitrogen by 1 kilogram. The data comes from SMILE microsimulation dataset, which is a combination of the most important data from the Census of Agriculture, the National Farm Survey, and other sources that provided this data-rich system. And then this model is thus spatial, it's economic, and it is very detailed when it comes to looking at the drivers. Next one. Thank you. So here on this slide, I want to show you a national level marginal abatement cost curve. I will take you through it. This is an aggregate of all of the measures that have been applied in all of the farms in Ireland. Here on the right-hand side, you can see the list of these measures. I will go through a few of them later on. So what this figure is telling us is that these measures are ranked from win-win situations on the left-hand side, which you can see the numbers that are negative. Those are those euros per kilogram. So those marginal abatement costs. Those are saving farmers money. But as you move more to the right, the more those become win-lose situations. So they save nitrogen, but they incur costs. Also, the general size, the width of these rectangles represents the total abatement potential. So essentially, the larger the rectangle, the more nitrogen loads can be reduced. Next, please. So here we're going into the geography of it, into the specific geographic context, and why that matters and how we can use that. For instance, for scale efficiency, when we compare two measures, such as cutting chemical fertilizer by 10% or by 20%, these maps are essentially showing us that in most of Irish subcatchments, it makes more sense from economic perspective to do more of this abatement, because per unit, it's more cost efficient. Next, please. Another one is localized effects. Some measures only make sense to do in some places, such as building fences around rivers. Here you can see these red areas in the north and northwest of Ireland, which are very, very red, which are places where it simply doesn't make sense to build livestock exclusion fences. Next, please. The same very similarly applies to feeding dairy cows low nitrogen feed. Here you can see the distribution of dairy farming, mainly in the south of Ireland. And that pretty much says that where there are more cows in subcatchments, the less cost efficient it comes to do the abatement. That's one important thing. Next, please. So now we're coming to win-win-win-lose situations. One of those is, for instance, increasing dairy breeding index, which would be increasing milk per cow, which means that if we have more milk per cow, then we can have fewer cows to satisfy the same demand. If they produce the same amount of nitrogen, then it both saves money and it abates nitrogen. So that's good for everyone. Next one, please. On the other hand, we have win-lose situations, such as increasing slurry storage efficiency. We know that leakage from slurry storage tanks is a big problem, but it requires farmers to invest an upfront cost to fix this. Next one. To conclude, the location of the subcatchments themselves and the distribution of the farms within those subcatchments are very important when we want to look at the cost efficiency of individual measures and their relative ranks. I didn't really go deep into why is that, what's the structure of the farming that really defines this. That's a whole list of both environmental and also economic factors that we are looking at in this study. This kind of farm level modeling system is that is sensitive to location, thus can be used for cost-effective design of targeted policy support. And finally, going back to the very beginning, combined with environmental models, such as the one that was presented by Yuting before, we can create that link between farm level economy and water quality, and that can help us in achieving environmental. Thank you very much.
Thanks very much. Thanks very much, Daniel. Daniel has developed a methodology to help us to understand the costs of implementing measures at farm level. And I guess some of his key findings is that these vary across space and both across farms.
due to that variation we mentioned in Yuting's earlier presentation. He described different types of measures, which have some that have costs, upfront costs, ongoing costs, and some actually that generate a win-win, where there's a win for the environment and a win for the farmer in terms of profit. But it's not all about economics. People change their behavior due to a variety of different drivers. And in our next presentation, we're going to hear from Niall McLaughlin, who's an advisor with ASAP, working for Lakeland Dairies, who will talk us through some of his research on the characteristics, the behavioural characteristics of win-win measures. Niall.
Morning, everyone. Just give some time for the slides to appear in front of you. Okay, so thanks for having me this morning. I'm going to talk to you about a piece of research I carried out with Cathal O'Donoghue and Mary Ryan last year, where we looked at what's called the theory of planned behaviour and how this can be used to understand environmental and farmer win-wins that Cathal just referred to there. So we're going to be looking at really environmental win-wins. So what's the need for this research? We know from I guess common sense and from various reams of scientific literature that there are many agricultural practices out there that have benefits for the environment and in this case specifically benefit water quality, and they also benefit the farmer's pocket through reduced costs or more efficient use of nutrients on farm. But continually we see that the adoption of these win-win measures is often low. So if you look at the usage of lime in the country or the amount of nutrient management planning that takes place and the implementation of those. So we really wanted to delve into that and understand it. So the objective of the research was to understand what it is that drives farmers' intention to adopt not just one water quality measure, but a bundle. So in this case, we looked at 5 water quality measures, and then to really apply what we learned to increase future adoption of water quality measures and how this can be used maybe in policy in the future. So to do this, we use what's called the theory of planned behavior, which I'm going to explain to you now. The theory of planned behavior is essentially a psychological framework that's used, it's used extensively in scientific literature and it's becoming increasingly used to explain economic behavior. And in this instance, we're really trying to explain why an individual farmer behaves the way they do or adopts a particular practice. So we try to identify what's driving that person's intention. So the research says that the greater the level of intention, the more likely it is that that individual or that farmer will undertake a given behavior. And then we really need to understand what's going on behind that intention. So intention, according to the theory of planned behavior, is driven by 3 key constructs. So those are beliefs and attitudes, subjective norms, and perceived behavioral control. So beliefs and attitudes. Does the farmer think that this measure is worthwhile? Is it worth carrying out? Subjective norms really looks at social pressures from important peer reference groups. And then perceived behavioral control really looks at farmer know-how. And to add to the explanatory power of the model in this instance, we actually added an additional construct, perceived resources. So that's really to represent cost barriers, so financial or time, labor costs, etc. And as part of this work, we looked, as I said, at a bundle of water quality mitigation measures. So specifically, we looked at soil testing, nutrient management planning, avoiding spreading slurry in high-risk areas, fencing of water courses, and the application of lime. And to do that, we needed data. So this data came from a 2017 survey where farmers were interviewed face-to-face. There was 1,009 of these conducted, and it was a nationally representative sample. And the interview is controlled for farm system, be they beef, sheep, tillage, or dairy, and for farm size. And there was 3 specific components to the survey. The first was really just collecting information on the specific system being run on that farm. And then the final 2 really looked at, the motivations behind adopting water quality improvement measures, and then the individual intention to adopt some of these measures. What we found, what you're looking at here, this is the results table. We're looking at the 4 constructs that we used as part of this model. So the 3 traditional ones, beliefs and attitudes, subjective norms, and perceived behavioural control, and the additional construct, perceived resources, and how they correlate with the 5 water quality mitigation measures. So nutrient management planning, soil testing, avoidance of spreading, fencing of watercourses, and lime application. And the pluses and minus represent levels of significance. So where you see 3 pluses, that's significant at the 1% level. So to explain that, I guess verbally, always is a lot easier for my small head anyway. We see that subjective norms and perceived behavioural control were strongly positive, and this was consistent across all measures. So that was a real take-home message from this piece of work. So what does that tell us? In simple terms, it tells us that peer behaviour and farmer know-how are really, really critical drivers of intention to adopt water quality measures. We've seen the beliefs and attitudes were positively associated with a farmer's intention to undertake soil testing and nutrient management planning, but not across the other measures. And finally, the interesting point to note is that we've seen perceived resources was negatively associated with the fencing of watercourses. So I found that quite interesting personally. And what's it really telling us? Maybe is it that intention to adopt water quality measures can be eroded or impacted by the higher costs incurred by particularly fencing a watercourse, and does it actually outweigh the influence of subjective norms and farmer know-how? And I'm not sure we exactly answered that question, but it may be worth researching in the future. And finally, how does this actually impact on future policy or through knowledge transfer in the future? So I think what we can take home is that subjective norms and perceived behavioural control are extremely significant, and that needs to be remembered. And we know from research, and we know from I guess even just common sense, that knowledge transfer groups and discussion groups are very significant drivers that can influence subjective norms and perceived behavioural control. So what do? By their very nature, they aim to increase the knowledge base of a group of farmers, but it also provides a very important social and peer group for farmers to come together and share opinions and ideas. And these platforms will also provide an opportunity, in time to further change beliefs and attitudes around some of the water quality mitigation measures. And this is applied to across 5 measures, but this could in theory be applied across many other measures. And finally, and I will finish on this, is that understanding perceived resources, i.e. the costs incurred of implementing measures on a farm, and the ability that those costs have on influencing intention is really key to identifying areas, I suppose, that may require financial incentives to increase adoption. So those were the key take-home messages, and that's the piece of research that I worked on. Thank you.
Thanks very much, Niall. It's great to hear somebody who spans both the front line as an advisor, who taken research as part of a graduate program in the university. I guess some key take-homes, different types of measure, different drivers, but uniformly across measures, the importance of social norms or the influence of other farmers is really important. And know-how, so that the knowledge to be able to implement what are often quite complex measures. Surprisingly, as an economist, the resources vary depending upon the measure, or maybe it's unsurprising, with differential influences depending upon a measure has a win-lose for the farmer relative to a win-win. So interesting angles on how to, I guess, support the rollout of measures on farm. We're now going to be joined by a couple of discussants. And the first I'd like to introduce you is Professor John Curtis of the Economic and Social Research Institute. We were colleagues together, office mates. I think it's 30 years ago when I worked with him in the ESRI. So it's really good to have John and his expertise as environmental economist on the panel today. I'll hand you over to John. Thank you.
So good morning, everyone. Thank you, Cathal, and thanks to the WaterMARKE team for inviting me today. I suppose it's very welcome to have the project complete and some of the research already out there published. I think it's very important body of knowledge to what is a very long history in this type of research. One of Uting's co-authors on one of the WaterMARKE papers, Karen Daly, was publishing a paper on this exact same topic back in 2002. I'll tell you the title of it: Modelling Phosphorus Concentrations in Irish Rivers Using Land Use, Soil Type and Soil P Data. And I would say, the overall message of the paper back then hasn't changed from today, but what has changed is that the methods and the capabilities of research have moved on, and I think we have much more precise and a better understanding as research and knowledge. That's what it's for. But I think it's giving added value to the policy dimension to tackle this issue. One of my earliest, work in this was looking at water quality in lake catchments. We focus on lakes because we were wanting areas that were hydrologically independent, because it is a very complex, catchments start way up in the highlands and cover lots of activities. But I would say one of the interesting things that we found from that research was that the impact of what happens in a catchment is not linear. Big catchments are not just scaled up of small catchments. And this is coming through, I think, in the work you've just seen this morning, in terms of, there's different responses across, not all catchments are equal, and there's a non-linear or a complex relationship. And then I suppose another, just to say how things have moved on over the years, we're all familiar with Teagasc's Agricultural Catchments Programme, which is bringing a lot of, field-based lab science, and that's moving, the research and knowledge along. And I suppose one of the things I wanted to, or two things I wanted to focus on today was the first one being that it's not just an agricultural issue. We're here talking about agriculture this morning. Teagasc is centrally involved in this research project. But really, from my perspective, it's a catchment issue. Agriculture is part of a catchment, but there are other things within the catchment, and we need to analyze and research and do policy, not so much from a farm level. Farms are obviously important, but it's at a catchment level. It's where it's relevant, and that was what you saw in the previous presentations. The second thing is, it's not just a science issue. So yes, it is soil science, it's agronomy, it's how weather and climate and all these other things interact with the soil and what ends up in water. But it's also a social science issue. People are involved and behaviors are involved. So we can't, it's essentially, we need to tackle those issues in driving policy. So it is not just, and this is where in this project you have scientists as well as economists and it's not just economists, it's psychologists and other types of social science. And agriculture itself is well known to responding to, my first point there was, I was going to say, the other thing it's a policy issue. And we all know how agriculture, responds to incentives, whether it's, within the policy landscape, or within markets. So that was the sort of first thing I wanted to focus on, that it's not just agriculture, it's within a wider scope. But the policy areas is the second thing I wanted to focus on. We have a long history of agri-environment schemes or agri-environment policy in the country. And the fact that we're here today talking, that we have this research project, that we're here this morning talking about it, it's saying to us that those schemes and policies are not working adequately enough. If everything was hunky-dory, we'd be talking about something else today. So, like, from where I'm looking at it, I would say that as policies are applied, they can be within them quite complex, and all criteria for whether the different schemes we've had in the past, the thresholds and these kind of things may be complex. But overall, the policies, I would say, are relatively basic or crude in the sense that they're often applied at national level. Now, there may be slight variations across the country, but what we've heard this morning so far is, that the science occurs at local level within catchments. The other thing is that, the national policy or policy agri-environment schemes, they're slow in learning and updating from the research. Like we see the CAP renewal, it's on the 7-year cycle. We have this slow process of change and update, where what we're trying to achieve is very precise. It's within small geographical areas, trying to keep nitrogen and phosphorus in waters within it's very precise, yet the tools that we're trying to achieve it are not so. And I think this in that sense, policy needs to link up, and this is why this WaterMARKE project contributes and is so important for that. And my takeaway message from what I've read in advance of this morning is that policy needs to focus at local or catchment level. That was very clear from the speakers before me. I think what we haven't addressed, I think in agri-environmental policy is, and it's not just agri, it's the assimilative capacity within catchments. On the agri side, we often focus on, if you want to call them farm level caps, or how much a farmer is allowed to do. But the farmer and the farm is situated within a catchment, and it's the catchment how that deals with and can assimilate inputs into the water stream. And then the third thing, and the final thing I would say is, policy needs to move on to, we've tried command and control at various levels in terms of putting limits on things and such. Ultimately, they may work to a certain extent, but they don't work well enough. So we need to, from a policy perspective, move much more substantially into the behavioural element. And ASAP is the first element of that. I suppose it's still I think it's it's not national yet. It's focused on special or on priority areas, but behavioural, we need to get farmer, you need to bring them on board with you. You can't talk at someone, you need to talk with them. But ultimately there's a lot more that needs to happen there. So with that, I'll wrap up. Cathal.
Thanks very much, John. So you talk about, essentially, it's not just an agricultural issue, and it's not just a science issue. I guess that pretty much aligns with the themes across this project. The behaviour is important, and that maybe command and control is a challenge. I'd like now to hand over to Professor Stephen Hines, who's Director of the Socio-Economics of the Marine Research Unit at the University of Galway. And I worked with Stephen for very many years. He was my first PhD student, and leads the nationally important research institute focusing on marine issues. Stephen.
Thanks, Cathal, and thanks to everyone for all your presentations. It's very interesting. Mary was asking me to maybe just make a comment and ask a few questions to Daniel and Niall in particular. Like John, I suppose I've been looking at this area myself for a good number of years, but maybe more so from the benefit side. Myself and Cathal, going back the years, have looked at what the ecosystem service benefits might be from the delivery of good water quality standards under the Water Framework Directive, and indeed myself and John as well have looked at this from a recreational benefit perspective as well. So slightly different viewpoint. Yeah, so very interesting, 3 very interesting papers, but maybe just conscious of time, so it just maybe in terms of Daniel's presentation, I thought this was interesting. You are using the spatial microsimulation model as your data source. I was just wondering there, again, it's something I would have worked with in the past. Is that farm level simulation model? But just you're using the national level model, if I understand rightly there. So the matching is taking place between the census of agriculture and the National Farm Survey, and the matching variables would be size and system. Is that correct? So I'm just wondering, your thoughts on the appropriateness of that in terms of using that as your base data. Will that pick up on, I suppose, the hydrology of the catchments and the particular farm types there, or was there a different matching process used there? And the other thing, I had a copy of your extended abstract as well, but I'm just wondering about the actual models that you use. And you made a comment in the end there that you didn't go into too much detail on that, but just you're looking at the distribution of the costs of abatements and getting from the models to deciding which are the most cost-effective set of measures for each of the farms, if I understand correctly. So I'm just wondering, how do you get from that starting point to the end? What are the change in those costs? What are the models you're using to achieve that? And even you're fixing slurry tanks. You had a map there again. Just wondering, how do you decide a farm needs to fix their slurry tank? So again, just a bit of clarification, I suppose, from my perspective. Niall, again, very interesting presentation. Looking at using the theory of plant behavior to look at the intention to undertake certain measures. Just wondering, in your case, I noticed from again the paper that I was sent you. I noticed you only use some subsamples are used for looking at certain measures. So, for example, I just was wondering why it was only 370 observations. They seem to have been asked about their intention to undertake liming, and I was just wondering why was the whole sample not asked that question? Probably a simple answer to that. And the same with a few of the other ones as well. It's subsamples that seem to have been asked the Likert scale questions, if I understand correctly. And then also, how were those who actually have already undertaken some of these measures? How were they treated in the data set as well in terms of the modeling intention? And I thought they had just one other final thing. I thought it was interesting that the influence on the beliefs and attitudes on the individual's intention to undertake nutrient management planning and soil testing, that was positive and significant, but then it was insignificant for the effect of beliefs and attitudes was insignificant driver for the other measures of the avoidance of spreading, fencing, and the application of lime. And I just wonder your thoughts on why it might be, why beliefs and attitudes might be insignificant for those particular measures. So I'll leave it at that, if that's okay, and give you a chance to maybe answer those questions.
Thanks, Stephen. Stephen is interested in some of the modelling aspects of what are relatively complex models and spatial analyses. We're going to come back to those in discussion later on. Have some of the questions, but just to let you know, as an audience out there on the internet, that we'd very much welcome questions from you that we can discuss towards the end, and you can put your questions in on Slido. So we're now going to move to the part 2 of the morning session, and I'd like to welcome a colleague of ours from Teagasc, who's a postdoc on the project, Dr. Paula Cullen, looking at factors underlying the uptake of measures within the ASAP program. Paula's here with me in Athenry, so I'll ask Paula to speak.
Okay, so the focus of my research within WaterMARKE is on water quality mitigation measures and understanding the characteristics of higher uptake. Next slide, please. So in particular, there are 2 main questions we hope to answer. One was, what types of farms are adopting measures? And to answer this, we conducted a logic regression looking at characteristics of farms that undertake at least one mitigation measure versus those that have not. The second question that we were looking at was what types of measures are adopted. So to answer this, we've conducted a multi-level mixed logic regression to understand the characteristics of measures undertaken with respect to whether they align with farmer norms, knowledge needed, and the costs involved. Next slide, please. So the data we are using comes from ASSIP, the Agricultural Sustainability Support and Advisory Program, which Niall is a member of, who spoke before. And they undertake farm-specific assessments and develop plans to prevent impact on water quality, agricultural impact on water quality. So it consists of 43 advisors split between Teagasc and the dairy co-ops. And since 2018, they have conducted over 3,400 farm assessments on farms identified as being possible sources for pressure on waterways. On these farms, they've found an average of 5.2 issues, and they then propose mitigation measures that the farms can choose to implement. Next slide, please. ASSIP have developed a database of issues that affect water quality and mitigation measures to address them. There are 44 different issues in the categories of land management, farmyard management, and nutrient management, and there are approximately 500 different mitigation measures in the database that they use to address these issues. The majority of the measures are recommended less than 50 times, but some over 500. The most recommended measures and issues are there in the table. So some of the most popular one they use is adhere to buffer zones and safeguard zones, prevent livestock access to water, manage critical source areas, and avoid application at high-risk times. Next slide, please. So as part of ASSIP's work, they have collected information on adoption of measures for the issues identified in each farm. And they found that 89% of farms had adopted measures to address at least one issue on their farm, with 64% of total issues having had measures started, completed, or ongoing. The analysis presented in the next couple of slides is looking at the differences between adopters and non-adopters, i.e. the 89% versus the 11%, and they're looking at the issues that were addressed versus those that weren't. Next slide, please. This is a summary of the first analysis, looking at what makes a farm more likely or less likely to undertake some mitigation measures versus not doing any. We found that dairy farms were more likely to be adopters compared to other systems. Additionally, farms with point source issues were more likely than farms without point source issues to be adopters. On the other side, farms with a risk of diffuse nutrient losses were less likely to adopt than those without. This seems to indicate that the visibility of the issues to the farmers influences adoption, or it could relate to differences in the type of measures proposed for the different types of issues. Agri-scheme participants were more likely to be adopters, which may be due to experience in undertaking environmental measures in the past. Additionally, farms with higher number of issues identified by ASSIP were also more likely to address at least one issue. And then finally, on the right, the larger farms were less likely to be adopters. Next slide, please. Following on from the previous analysis, we wanted to look at to have a bit of understanding of the types of measures that farms were willing to undertake. Past research presents the theory of planned behaviour as a way to understand people's intentions of doing something. And Niall went into a bit more detail about this in his presentation. So simply, this proposes that intentions are influenced by attitudes towards behaviour, subjective norms, or whether most peers approve of the behaviour, and perceived behavioural control, or whether you have the resources or knowledge to undertake the behaviour. To better understand the uptake of measures, we obtained expert opinions of parts of the theory of planned behaviour for each measure in the ASSIP database. This included estimates of the alignment for each measure to farmer norms, the knowledge needed to undertake the measure, and costs, both direct, such as upfront costs involved, as well as indirect, such as the loss of productive area. These were used in a regression looking at adoption of each measure. Next slide, please. These are some of the key results from the analysis, which was conducted for all the issues and then split also into the 3 issue categories that we can see there. As some aspects of the measures, particularly the costs, differ quite significantly for each of the different issue categories. We found that measures with a higher alignment to farmer norms results in a higher likelihood of the farmer will undertake the measure, which was expected from the theory of planned behaviour. What we didn't expect was that the higher the level of knowledge needed for a measure, the more likely the measure was undertaken. I'll go over some of our theories for this in the next slide. Additionally, 2 of the cost types showed a negative association with uptake, upfront costs and loss of productive area, which is what we expected. Next slide, please. So this brings me to some of the conclusions from this work. One is the complexity of the work that ASIP does, with a large number of issues and measures that the advisors need to be knowledgeable on to generate an appropriate plan for the farms. This makes it difficult to mainstream advice for general advisors, which is one of the goals at the beginning of this work. We also found that there is significant knowledge needed to undertake the measures. However, there is a positive association with knowledge needed and adoption. We have a few theories as to why this might be. One being that higher knowledge measures might have a higher impact, so it might make it more likely that farmers will want to undertake them. Another possibility is that the advisors spend more time explaining complex issues, which makes the farmers prioritize them. Next slide, please. So another key point from the analysis is the importance of costs to the adoption decision, particularly upfront costs. ASIP is a voluntary program and currently no direct financial support is available from ASIP to help the farms they visit, which is an area that could be for policy intervention in the future. Finally, the high adoption rates on ASIP farms are a hopeful sign for the future of water quality in Ireland. Thank you.
So thank you very much, Paula. I guess if listening to some of the things that jump out at me is really how impressive the ASAP program is. It wasn't there when we started the program, and if it hadn't been there, we would be recommending that it should be. And just the professional expertise of the team there is very impressive. It's a great asset to finding solutions to these issues. Another thing is just the sheer scale of the number of measures that we're asking farmers to undertake, and also asking advisors to advise on. When we kicked off the project, we were kind of thinking of what directions we'd be going in, and I guess our initial sense is that we'd be advising to mainstream agri-environmental advice amongst advisors. But when you see the scale of expertise required to advise on water quality matters, it strikes me that it's probably a greater degree of specialization that's required. And just given the expertise that's necessary to advise farmers on such a wide variety of measures and in a wide variety of different contexts. So I think it's probably something which we've changed our view on since the start of the project. So I think that kind of neatly brings us on to our next speaker. Is PhD student at the University of Galway and Teagasc, a psychologist. And as we move from taking a quantitative perspective in many of the previous analysis to a qualitative perspective. And Rosella will join us to talk about behavioural perspectives. Over to you, Rosella.
Thank you, Carl. So for the purpose of this brief presentation, I will describe some of the data from my PhD project, which focused on farmers' engagement with pro-environmental water quality behaviors, on understanding farmers' engagement with pro-environmental water quality behaviors. So what you see on the right is a simplified version of the agricultural innovation system, which is a system that involves all the stakeholders that bring about change in agriculture. And as you can see, farmers are the very last actors of this long chain of other actors. And they are the most targeted population because they are the people who need to engage in these pro-environmental water quality behaviors. So we focused on farmers, and the research question was, what are the barriers and facilitators for farmers in engaging with pro-environmental water quality behaviors? And we decided to adopt a bottom-up approach. So we designed a focus group and interview study with 16 Irish farmers. But then we moved upstream the agricultural innovation system, and we focused on the most proximal source of social influence to farmers, which are advisors. Advisors are often believed to be able to influence farmers' behavior. That is why we asked what were the barriers for advisors in supporting farmers' pro-environmental water quality behaviors. And we adopted again, a bottom-up approach. So we designed a focus group and interview study with 25 Irish agricultural advisors. Part of them belonged to business and technology advisors, and part of them belonged to ASAP advisors. And finally, we developed a sort of a farmer behavioral readiness assessment for advisors to be completed, which was part of the ASAP survey that Paula was mentioning before. And so advisors basically had to evaluate farmers' knowledge, skills, motivation, resources, and social support in implementing pro-environmental water quality behaviors. So we compared the results from the first two qualitative studies to understand what were the points of agreement and points of disagreement between farmers and advisors. So, of course, there were many points of agreement. For instance, both farmers and advisors perceived that regulations were actually a barrier, were actually being barriers to farmers' engagement with pro-environmental water quality behaviors because they are often perceived as impractical or unfair to the farmer. But for instance, the trust in advisors was something that was mentioned as a facilitator by both advisors and farmers, although advisors think that this trust does not come with them just being agricultural advisors. It's something that needs time to be developed in the relationship between the farmer and the advisor. Many of them agreed, both farmers and advisors, that there are psychological issues preventing farmers to engage with pro-environmental water quality behaviors. Farmers think that it might be in relation to fear or anxiety, while advisors think that it might be in relation to farmers' age. And also another point on which they both agreed was that there is a need for financial supporting these farmers who need to engage with pro-environmental water quality behaviors. So they both identified that farmer finances are a barrier to farmers' engagement. There were also points of disagreement, and they were mostly in relation to farmers' motivation and knowledge. So while farmers believed that they had enough knowledge to implement pro-environmental water quality behaviors and enough knowledge of the issues around water quality, and that they had interest in preventing the degradation of water quality, advisors were not on the same page on this. They think that farmers do not possess the adequate knowledge to implement pro-environmental water quality behaviors, and that they are not interested in this. And what's more important to this is that they mentioned these barriers in relation to farmers' behavior as their own barriers to do a good job to support farmers, because if the farmer is not interested in discussing about water quality, or as does not possess the adequate knowledge to understand that they are being problematic for water quality, this is an obstacle to advisors' motivation to bring the topic to the farmer, especially for business and technology advisors. And so there might be some explanations to this difference. For instance, we might have contacted farmers who are already more keen to implement pro-environmental water quality behaviors, or more informed and more open to discuss about water quality. And there might also be the case that advisors are presenting us with some biases, for instance, information bias. If a person does not implement a behavior that we want them to implement, we tend to think that they are not adequately informed about this. Or advisors might also present us with negative biases. They might remember problematic farmers more than farmers who actually engage with pro-environmental water quality behaviors, because they need to put more effort in these farmers who are being problematic about this. So who has returned the most realistic picture of reality? So the ASAP survey helps us in this direction. So it helps us understanding that there are differences among farmers' cohorts in terms of their behavioral readiness. So, for instance, if we compare cattle breeding and mixed farming with dairy, we can see that they have a lower knowledge to understand what are the issues around water quality and how to implement pro-environmental water quality behaviors. And interestingly, there are differences among farmers who engage in activities producing P diffuse pollution and farmers who engage in activities producing N diffuse pollution in terms of their behavioral readiness. It seems as though that farmers producing P diffuse pollution have lower knowledge, while, for instance, farmers producing N diffuse pollution have lower skills to implement pro-environmental water quality behaviors. Now, one important factor is that farmers' engagement in agri-environmental schemes, for instance, has a positive effect on farmers' motivation when it is related to habits. So basically, they are more used to thinking pro-environmentally and to implement pro-environmental behaviors. And this is a facilitator. And interestingly, farmers who are in bigger farm systems seem to be more ready to implement pro-environmental water quality behaviors from a behavioral perspective. So they have increased knowledge, increasing skills, increasing motivation, and also increased resources. So the take-home message is, first of all, the farmer-advisor relationship is bidirectional. So as much as advisors are able to influence farmers' behavior, farmers are able to influence advisors' behavior. So the relationship has to be thought as bidirectional. So farmers' level barriers play a role in advisor ability to support farmers. And that is why there is a need to assess multiple stakeholder barriers and not only the farm level barriers. Of course, there is discrepancy between what farmers and advisors think in terms of knowledge and motivation to engage with pro-environmental water quality behaviors. And this has several explanations, but the reality is that there are actual differences among farmers that need to be addressed in terms of behavioral readiness. And when we develop interventions about this, we need to target these interventions to the farmers who are in most need of this. Thank you.
Thanks, Rosella. Nice point there at the end. Rosella, in taking a qualitative perspective, helped us to dig below the numbers. The numbers only go so far. You need to talk to people to get into their heads and understand what drives them. key word that jumped out at me from Rosella's presentation is trust. In order to get things done, you have to build trust. It's hard won and easy lost. We see that farmers and advisors take different perspectives. Sometimes they have a similar perspective, sometimes they take a different perspective, but that relationship is bidirectional. It goes in both directions, and sometimes we forget that. It's about working with farmers to find solutions rather than telling farmers. That listening aspect is very important. And Rosella, I guess in today's proceedings, brought forward the concept of systems. If we want to change farmers' behavior, we need to look at the people who influence farmers, and they and we may also need to change our behavior. And that kind of neatly brings us to the next presentation, Professor Mary Ryan, who is going to talk about a systems concept known as innovation system. I'll hand you over to Mary now.
Thank you, Cathal. As Cathal said, I'm going to talk about the entire system that can influence farmers' behaviour in relation to water quality. I'll just wait for the slides to come up. But this is a piece of work with some colleagues here based in Athenry, Laurie Raven Larn and Kevin Kilcline as well. Next slide, please. The whole innovation systems thing, we have decided to work with a particular framework which is reasonably new, and it's about innovation ecosystems. And because it's centered around ecosystems, it's being used more in the literature now to describe and work with whole systems that are fundamentally based on complex science or biology. And of course, that fits our complexity problem really neatly. In order to diagnose the functioning of an ecosystem that influences farmer behaviour, we look first at the actors. You'll see on the left there, they're influencing actors, policy regulators, farmers' representatives, NGOs and consumers, research actors across the private and public sectors and the universities. Enterprise would be more to do with processing, value chain and the market. And then intermediaries, which we focused a lot on in this project because we were specifically looking at knowledge exchange. We're talking about advisors by and large, and again, public and private sector advisors. And all of these different actors influence farmer behaviour. And we categorised farmers, just for the simplicity of this exercise, in terms of farmers that are in areas that are high risk and farmers in areas that are low risk, but also in terms of intensive versus extensive farmers. And what we want to look at are not only the presence of the actors in the system, but also the connections between the actors and the different infrastructure components within an innovation system. So next slide, please. This is quite busy, but essentially we've colour-coded the different types of actors. So the red actors are the influencers, the Department of Agriculture, Department of Housing, Local Government and Heritage, and then the regulator being EPA, and also at a local authority level, LawPro, which is the local authority's water programme. And they all interact with each other, but they interact in terms of largely national incentives. This was in 2018. We diagnosed the innovation system that was current in 2018 to see what the different interactions were. You can see that research again is connected to national information. And at the time in 2018, ASIP hadn't been set up, and LawPro wasn't there that long. So most of the advisory or the advisory information was national as well. And just next, click it on there again. So the focus at the time was on national level policy, regulation, research and advice. And one last click on this one. And the focus the diagnostic at the time was that the focus of the actors and the institutions and the incentives needed to be more localized and more collaborative. So move on there again, please. So just to summarize it, one of the things that came out in terms of getting all the actors together in one room to look at this was that everybody was working hard, but not necessarily everybody was working with everybody else within the system. So it was interesting from the actors' perspective to bring everybody into a room together. The intermediaries, as I said, need to develop more specialized knowledge. On the enterprise side, which is essentially the marketing, it's really challenging for something like water quality to develop a mechanism for the market to directly reward improvements in water quality. So there's a challenge there. In terms of the research, there's also a challenge because we need more and we need more localized spatial information, and the researchers also need greater temporal resolution in terms of maybe more closer to real-time monitoring. And in terms of the influencing actors, they need to, this was the diagnosis in 2018, they need to move towards more localized policies and regulations. Next slide, please. So in 2023 now, we're taking a look back to see what has changed in that process. And we're inviting feedback from a group of experts again in terms of what they see as the changes within the innovation system. In terms of our changes within the innovation system, our what we see as changes, we're giving you kind of what we see happening, and we'd like feedback then from people in terms of if they have, you know, things that we're missing or things that have been done differently in the interim between 2018 and now. So next slide, please. So, okay, looking quickly at the policy and incentive changes in terms of policy, we're looking at more nuanced nitrates regulations coming in since the new CAP, and where the nitrate limits will be banded on the basis of the yield of herds, and also where derogation will be tied in with water quality in a local area. But as we saw from Yuting's slide, there, you know, there's been quite an increase in livestock numbers. Will that be sufficient to mitigate the livestock numbers? In terms of the incentives, which are voluntary, and the new acres agri-environment scheme is kind of the end in a current progression from through REPS, EOS, GLAS, and now acres. It's more needs-based, particularly in relation to water quality issues, and it's underpinned by catchment science principles with break the pathway measures. So break the pathway of loss of nutrients or sediment to water. Particular measures like less low input grassland, extensive grazing with a maximum nitrogen limit, and tree planting would all be important for water quality. Next slide, please. On the measurement and monitoring and information and research side, the agricultural catchments programme provides real-time monitoring and measurement for 6 catchments, which cover a lot of kind of different catchment types in the country, but it would be challenging and expensive to generalise to different environmental contexts and different catchment characteristics to cover all of the country. The EPA have developed pollution impact, it won't come to me now, but it's pollution impact potential maps, which look at critical source areas and are much more useful now for the likes of ASIP advisors in terms of localized information for highlighting where risks are likely to occur and how to target the areas where these measures need to be targeted. And in the meantime as well, the EPA obviously are funding a lot of projects in this area, and a lot of projects that are becoming more and more localized, like the Smarter Buffers project that's specifically just looking at putting the right buffers in the right areas. In the meantime, the WaterMARKE project, how have we contributed? One of the biophysical work package led by Karen Daly in Johnstown Castle, co-designed on-farm drainage measures and disseminated those to ASIP advisors. In terms of the spatial analysis, UTing highlighted that there is considerable fluctuation between different water quality classes, both into and out of high status, and that also changes outside of the high status across all the classes, from bad all the way up to pristine. Next slide, please. Okay, and just in terms of the actors themselves, at the start of the project, there were the priority areas for action were published in the middle of 2018, and that was very much a participatory approach involving the regulator and the Department of Housing, Local Government and Heritage, LawPro, and catchment scientists. And once they came up with a potential suite of priority areas for action, LawPro undertook community-based, bottom-up interactions in order to get the opinions of the population at large in terms of the priority areas for action. Once they were defined and in place, then the ASIP process is very much collaborative, where LawPro identify the areas that are at greatest need, and their community officers set up community meetings to inform the community as a whole what's happening, and then ASIP are part of this process and they take over in terms of looking at agricultural or on-farm referrals. There's also a much stronger move towards knowledge exchange, in that LawPro, ASIP and farmers are very much working together. It's not a kind of a top-down, the advisor says that what you need to do is A, B and C. It's very much a kind of what will work for you on your farm, what do you think? And in terms of work that has been done in the project, we've looked at the behavioural characteristics of farmers and advisors in relation to water quality improvement, and there's some very nice lessons there from Rosella about trust in advisors and level of knowledge, and also from Niall in terms of the characteristic of win-win measures and also the characteristics of the ASIP measures themselves from Paula. Next slide, please. So we looked at, would there be potential? And this is a question that has come in on the chat as well. So we looked at, would there be potential to mainstream ASIP across mainstream enterprise advisors? And one of the results that came out of Paula's is that the complexity of the measures is such that you have over 300 measures that are applied in 44, I think, 44 issues in 3 different risk contexts, the farmyard, nutrient management planning and land management. And essentially there is so much complexity that when you try to analyse it and see patterns in the data, the whole thrust, I guess, of ASIP is to be able to provide localised information to suit specific farms in specific contexts. And the problem is that it certainly would be very challenging to try and generalise this. Next slide, please. And then in summary, in terms of the changes that we see, there's more of a participatory approach among the actors. There's more nuanced nitrates regulations, but will it be enough? There are big developments in terms of the AES schemes, but the schemes are still strongly focused towards biodiversity in relation to the results-based component. The challenges that we see are ASIP approach is working well in the PAAs, but it's challenging to mainstream. WaterMARKE emerging issue is the one that we see very much coming out around costs, and there's no current mechanism to cover additional regulatory additional works that would be above and beyond what farmers are actually required to do. And Daniel's cost effectiveness work shows that the application of measures varies hugely across farms and across local contexts. Next slide, please. So that's it. It's very much a move away from knowledge transfer to knowledge exchange and co-learning across the intermediary actors. And there are very strong linkages now across all the intermediaries. And the introduction of the behavioural research has strengthened and will provide more underpinning for those interactions. Next slide, please. So this is an initiative that is being undertaken by a large group of the actors that I've spoken about in terms of ASIP and LawPro and the dairy co-ops, looking at how to go further and how to put in place mechanisms for farmers to be rewarded for cost, but also for farmers to be rewarded for going that extra mile and to having greater impact within the innovation system and in terms of improving water quality. So just last slide there, please. So the conclusions very much, water is an externality, which means it's a public and a society problem, and society may not be involved in we'll say declines in agricultural water, but all of us are responsible for declines in water, as I said at the beginning. Improving the local environmental externality means local solutions, local information, local incentives. Changing the behaviour means we have to look at everybody's behaviour across the information system. And the most effective solutions vary across farms. So there are differences across space in applying solutions, and that needs to be taken into account. And hopefully that'll be one of the impacts that comes from the new EIP once that's fully up and running. And just as a final, last slide there, sorry. Just as a final take home from my side, I guess, in wrapping up the entire project and the innovation system analysis, is the word that keeps coming up is complex. Everything is complex. The science is complex. The mitigation is complex. And what that is saying is that there needs to be more awareness and more knowledge for farmers of the problems and how they can mitigate them. But that needs to be done in very much a knowledge exchange framework rather than just feeding farmers information. We need to keep getting their feedback. The incentives are there through regulation, the voluntary incentives, and it came up in Paula's work and in Niall's work and in Rosella's, that social norms and trust of advisors is huge. And that needs to be taken on board in terms of designing both new regulation and new incentives. And the costs, again, are coming up as a barrier in all the analyses, and that needs to be taken on board. If we want farmers to undertake measures that are more costly to them in terms of money or time or hassle or nuisance, then we need to take that on board also. And I think a lot of that will happen within the new EIP, but they're the main take homes from the project as such. Thank you.
Thanks very much, Mary. There's it's a integrating presentation that brings all the various different dimensions together, and thinking about things from a systems perspective. We often talk about trying to find solutions to complex problems using systems. We had the systems focus on the Food Vision 2030 strategy, but in reality, most people are comfortable working in their silo, in their own particular cog of the overall system. It is hard to get people to work coherently together in the system. People have different expertise and different interests and different knowledge, and it's a challenge to get it all moving together. A word that Mary used a few times is ecosystem. So it's not just about the environment, but about the system of people as well, which are sometimes we're more complex than the environment. One of the things that came out of Mary's presentation is the focus on behaviours and levers of different actors across the system, and how, and going back to John Curtis's remarks, many of those are national focused, where they need to be local focused for water quality improvement. If we look over the period since this research programme started, we've seen a very significant improvement in the coordination and engagement between actors across the innovation system, but there's more needs to happen. So we're going to finish with with the speakers with discussants on this section. I'm going to introduce a former colleague of mine in Teagasc, Ger Shortall, who's a regional manager, and before that he headed up the Agricultural Catchments Programme, which is a really innovative research and extension programme run by Teagasc and associated with external bodies, and worked in the Commission as well. So over you, Ger. I think you're on mute, Ger.
I was diligently muting myself there, so I've unmuted myself now. So, no, I'd just like to say they were excellent presentations, and to pick up on the theme that you brought up, Cathal, the very, very complex topics and very complex issue, and there's going to be necessarily complex work to be done to solve them. So I suppose just kind of give my take on a very quick few thoughts about the papers there. Looking at Paula Cullen's paper and her presentation, what struck me was the measures which are most commonly taken up are the ones which are focused primarily, it just struck me, on phosphorus. And she alluded to that in her paper, that perhaps this is because they're more visual, more obvious to the farmer, maybe easier to communicate about. But there seems to be a strong emphasis there on the phosphorus type measures around point sources and the pathway intersections and so on. And they're more difficult, are more, I think, more straightforward maybe to communicate about. There might be quite complex mechanisms involved there, but I think the fact that they're visual and that the farmer can relate to them, the farmers are used to talking about water movement and drains and so on, maybe that's having an impact. And what it's probably doing is it's overshadowing the requirement there to look at the nitrogen side of things and the nitrate losses. And I suppose the part of the country I'm living in, nitrate is up front and center in our concerns regarding water, and Islania is in serious trouble with nitrate. And I suppose that diffuse problem is if anything more difficult and complex to tackle than other ones. So I suppose it'll be interesting to dig a little bit into the data there and see why why nitrate maybe isn't featuring as strongly as it might. Is it something to do with the selection of farms that already have problems on them, or is it an easier, or is it more intuitive for advisors to tackle those problems or whatever? I just don't know. I think that the higher was very, very hard to understand why the higher knowledge needs type measures were more likely to be uptaken. But again, is that something? Are the higher knowledge needs ones maybe related to the pathways and the P losses and the management of yards? I'm not sure. I think the knowledge needs around them are equally high, and they don't seem to have featured as strongly. So it'd be interesting to see why that is as well. I suppose the overarching idea or feeling I get from all this is that the complexity can only be addressed by a collaborative approach and a cross-industry approach to the ag innovation system. And I think advisors with the best will in the world are going to have limited amount of contact with farmers. They haven't the luxury of having continuous contact. So you're talking about dipping into a farmer's life and his business for maybe very intense engagement for a matter of hours, and then maybe not having much contact again other than via maybe media or whatever. So I think that really emphasizes the requirement for other agents in that farmer's life to have to at least be on the same page as the ASAP advisor or the agriculture advisor or the private consultant. And I think that's innovation system. I think it's a little bit missing maybe from some of the discussion there. We talked about the processors and the regulators and the local authorities, but the people who actually speak to farmers in their own yards are probably people like sales reps, representatives of local organizations, or farmer organizations, whatever, and they need to be on the same page. And I think maybe sometimes farmers are getting varied messages around the topics from different sources. So we need to get, I suppose, there was a reference made there to bi-directional relationship between the farmer and the advisor. I think there's a multi-directional relationship there that farmers have with people in that agricultural innovation system. And if mixed messages are coming through, it certainly is going to weaken the momentum towards attitudinal change among farmers around water quality and mitigating risk to water. So I think a significant amount of work is required there to see how we can get that collaborative approach working more effectively. It's certainly ASAP is a good example of how it can begin, but I'm not sure at farm level that it's having the impact it could. I suppose in terms of knowledge gaps or maybe further research, I think on the agronomy side, which you wouldn't necessarily think agronomy research should have much impact, I suppose, or should be a need there when we're looking at water quality issues on farms. But we see among advisors real issues there. A farmer says, I'll implement this strategy, okay, or what happens if I implement this mitigation measure? What impact is that going to have on my productivity? And it's not always easy to answer that one. Or will it have any impact, or will it be cost positive or negative? So, for instance, one that comes straight to mind to me is in this neck of the woods, especially for mitigating end loss, would be, say, for instance, something like cover crops being used on spring cereal areas and stubbles. We've quite a lot of work done there on mitigating potential of those cover crops, but we don't have enough information on the consequent impact on production. And is there potentially savings there from all that end that we're capturing? So there's one area where further research would be very beneficial. Similarly with multi-species swards and clover and so on, there's a lot of these mitigation measures where emphasis is probably been placed on the mitigation capacity, but giving good sound advice on the consequent impact on agronomy is maybe sometimes we don't have the good information we need on that one. Other than that, I suppose, look, the complexity of the problem, I think lends itself to, as I say, a collaborative approach, an inclusive approach right across the sector, and maybe we're just beginning on that road. I think the processors, the purchasers, the supply side, all the rural professionals that have interactions with farmers need to be on message, if you like, on this one. And I think that's where the real long-term gains can be made. Because farmers are a little bit, we interact with farmers at a survey or an advisory visit. We forget that for the other 365 and 3/4 days, they may not have much contact with somebody who's discussing these topics. So we need to increase the interactions, increase the number of channels that are getting the messages into farmers, and to make them feel less isolated and more supported in making what for them are very significant changes on the farms, and support them as well with more and better science. So I don't know if that's what you're looking for, but that's my impression.
Thanks very much, Jared. It's great to draw upon your expertise. Next discussant is Dr. Anthony Cawley, who is an economist in the Economics and Planning Division of the Department of Agriculture, Food and Marine, and former PhD student of mine as well. So, Anthony, interested to hear your perspective.
Thanks, Cathal, and good morning all. Yeah, so thanks for the papers. Very interesting, very important work, and obviously hugely important for the department as we build the evidence base for design and policies to try and meet these challenges that we're facing in the sector. So as already been covered in the presentations, the ASAP program, for example, is using a collaborative approach with industry, and we're building this out at the moment, and it's been extended now and it's ongoing. And the new EIP as well has a number of initiatives in there that use this kind of information to complement other initiatives like Acres, as Mary had covered. Just to offer a little bit of a reflection and going back to my own research where I was looking at the impact of knowledge transfer activities on farm level impacts, the papers today obviously show us very, very important insights, and Rosella's paper in particular shows us about those behavioural things that are happening for the participants of KT services, and this is very helpful. I found it very interesting that there was a difference between the advisors and the farmers in terms of what they perceive that they need to do, or if there's more learning to be done. So perhaps we could do a little bit more reflection there on a communications piece so that everyone has shared understanding and common understanding of these issues. Just on the motivation to participate in KT, we know that some types of farmers are more likely to participate and other ones are not likely to participate. And those hard to reach farmers, it's important that we consider those, as we need everybody to buy in to implement the actions that we need to meet these challenges. So it's just interesting to, those perspectives as well would shape ultimately the impact as we get here. And obviously we know that you can incentivize people to participate in KT or in extension services, but it's getting them to implement what they do at home. And that's the real key part of it. And my own research looked into this, and, that the farmer recognizes the benefits. So this is the win-win, that something is easy to use, that it's not overly complex, that they can visualize, or that they see a demonstration of the particular work. These are all very important. The content of what's being delivered is has to be relevant, and a combination of activities, because all farmers are different, all farmer challenges are different, and so on. So obviously this is very tricky when we're thinking about policy design, but it's that piece about implementation that we need to get there. So facilitating the learning of farmers, whether that's from the advisor directly or horizontally from their peers, these are effective ways of doing so. And those kind of things are very, very important. And then just quickly touching on Paula's work. So that showed us the adoption of some measures happened and other measures did not happen. And again, this comes back, I would imagine, to something that's more suitable, less complex, more easy to use, easily adopted, are the ones likely to be implemented first. And going back to my own research again, we looked at differences across management practices and which ones farmers were more likely to implement. And for things like breeding advice, it was more simplistic because it's something that people were doing anyway. Whereas grassland management advice was a bit more difficult because this could be seen as a cost, whether in terms of time or something new. And the implication of the consequence for not doing it today was not immediate tomorrow. However, we also know that those that implemented it were blown away by the results of it. So there is still that piece there, and that's why these behavioural things are absolutely critical for us to understand better so that we can design appropriate policy. And all those other factors that were mentioned in the presentations, absorptive capacity, the norms, all those things are very important as well. And obviously one size fits all doesn't work for this sector. So I think those points have been well covered. So I just conclude by saying thanks again for the presentations. Hugely important. The department is obviously interested in these results and looking forward to following the work as it progresses. And we all know the challenges that are ahead of us, and understanding this is the key to making us find the solutions and implement them. Thank you.
Thanks, Hansi. It's great to have some of your expertise taking research knowledge and implementing it in policy design and evaluation in the department. So the final discussant is a very good former colleague of mine in Teagasc, Dr. Kevin Hinu, who's the Teagasc evaluation officer, and really a go-to person in terms of systems and the way systems work in supporting goals within the agri sector. So over to you, Kevin. Good to see you again.
And you too, Colin. Thanks very much. And thanks very much to the WaterMARKE team for the invitation to join in with this today. It's been a fascinating morning. It's been really great to see the research that's been carried out as part of this project. And I look forward to seeing and catching up on the publications as they arise as well. And I suppose I was specifically asked to reflect a little bit on and comment on the usefulness of an innovation systems or a systems approach. Look, I mean, it's gone right through from the very first presentation here this morning that we're talking about a complex problem here. where the environment in its broadest sense, both the policy and the knowledge exchange and the actual biophysical environment, is changing and reacting to our interventions. So I think in the background, the whole challenge of improving water quality has been kind of conceptualized as mission oriented, very much so. And the challenge then is the system, I suppose, up to this. I mean, the innovation system literature has an approach has a long background, but it's typically until recently kind of focused on describing and mapping innovation systems. More recently, then I suppose trying to take a diagnostic approach. And using things like the coupled structural functional framework to diagnose what's missing in an innovation system and how that could potentially be, the system could potentially be intervened in to make it more likely to achieve its objectives. I suppose this particular, the water quality Ireland is a particularly interesting case as well, because right back to Charles Sable and Rory O'Donnell and the NESC pieces of work where they identified that there was something in terms of experimental governance happening in Ireland around water quality and the dairy sector. Going back to the kind of the 2015, 2016, and that whole notion as well of experimental governance, so that there was new configurations of the way to do things, that was very much to the fore as well with the ASSEP expert review that took place in 2021. So I think this is it's a particularly interesting context for thinking about systems type analysis and what's happening. Look, reflecting even on some of John Kirsty's comments earlier as well about the need to focus on catchments, and I broaden that out into a system, and the need to focus on the social sciences, not just the science view as well. And then ironically also needing to look at the local level and to focus on that behavioural space. So not dwelling too much on, but the presentation, particularly Mary's presentation, took that overview of the innovation system, and I think it's very fruitful to try and bring in that innovation ecosystems perspective as well. I think that's a fruitful addition to this. I suppose in addition to that helicopter view and that broader view, I was reminded of, and I think it resonated with some of Rosella's work around the readiness survey, that the whole approach in terms of the micro ACUS that was taken in the AgriLink project, the Horizon 2020 AgriLink project, and particularly their model of triggering change. So it's almost like looking at a system from the bottom up, from the farmer's perspective, and I think it would be very complementary to, in terms of what Rosella was doing and what Mark indeed, Niall, sorry, was indeed doing as well. Because what are those key points when decisions on farms can be triggered? And that's often quite a contextual piece, even in the farm family life cycle, but also nudged at times by policy and by knowledge exchange and by other interventions within that system as well. So even within that systemic approach, I think there is opportunities to learn from that, if you like, the bottom-up micro ACUS type of idea as well. I suppose the challenge around a lot of and this is a recognized challenge around a lot of the innovation systems approaches, is that they're not really all that good at dealing with two or three things. One is exnovation, as it's increasingly called, or that proactively trying to look at breaking down and phasing out of unsustainable systems within a context. I suppose the clue is in the name. It's an innovation system approach, not an exnovation system. But that goes back to the old approaches around unlearning particular practices, methods of interaction or modes of interaction, and behaviours and policy thinking as well. So that whole role of exnovation within a system, I think, is important. So look, more broadly, I think that whole piece about moving from describing and mapping and using innovation systems as a diagnostic tool to actually moving to try and evaluate, if you like, the impact of what is happening, those systems or particular aspects of those systems. What we've been talking about all morning here is huge. It's absolutely huge. And there's probably some merit in almost working back the way in terms of identifying particular outcomes or particular goals that are trying to be achieved, and trying to understand, by taking a theory-led evaluation approach, the causal mechanisms that underlie the processes to try and achieve those outcomes and that have helped to achieve those outcomes. And by doing that, we learn more about those systems that we're focusing on as well. So it's trying to unpack those processes, and actually all of the material that's been presented here this morning provides much and very diverse evidence to actually say something about how those processes can be unpacked by taking a theory-led approach to this particular evaluation system. So look, kind of rambling and selective comments. I think a useful place to look for some far more articulated kind of view on this is there was a very good paper published in Research Policy just early this year by Carolina Haddad and Anna Bergek towards an integrated framework for evaluating transformative innovation policy. And I think it could be a really useful and interesting way as you sum up some of the WaterMARKE pieces as well, to just look at the thinking that's happening there as well, and maybe to be able to package and present some of your information in a way that provides additionality and value added to your project. So look, thanks a million for the invitation. I think the work is great. It's been fascinating, and as I said, I look forward to seeing more about the publications as well.
Thanks very much, Kevin. Always insightful as ever, and thanks for your input. So just given the time, we're at our time. It's supposed to be to wrap up. Our plan is to produce a summary report of the event. Thanks to all who've both either commented as discussants or commented online. We will try to address. We're breaking up here. We'll try to address all those comments in the final report. Water quality is a really important policy question as we try to return the quality of waters back to the way they were and to the way we would like them. I think this event has really been excellent. Excellent quality, both in terms of the research undertaken. So thanks to all who've participated, both who've presented here and more wider in the project. For the comments from expert discussants and also from the questions that have come in to us on the chat. I really appreciate you all taking your time to engage with us today on what is a very substantial program of work. I'd like to acknowledge the funders and to thank the funders, the Environmental Protection Agency and the Department of Agriculture, Food and Marine. From a research point of view, it's quite kind of brave to fund something so interdisciplinary as this. Finding solutions to complex problems requires people to work together and look at things from different angles, and it certainly put the question to us, and we've done our best. I guess any interdisciplinary project is challenging. People from different areas, even if we have a similar perspective and similar goals, often we have different languages, different ways in which we work, different scopes and scales that we work. And so getting people to work from different disciplines is hard. It's hard. We've made progress here. But I think it is the way of the future. To deal with these kind of big questions, we need to be working together. Kevin, he used the word huge. This is a huge issue, hugely complex. And I think in every dimension we looked at in the project, it was probably more complex than we anticipated in all our own individual perspectives before the project. Water quality is something that affects people locally. It's influenced locally. And so the challenge is to go from national scale that we often look at, the lens we often take when we look at policy, we give advice, to going local, because the solutions are local, and we need to work with people locally. Just Shortall referenced the complexity of what water quality is. There are different angles, NP, sediment, and so on. So it is challenging. It is a challenging area. I think the research that we've undertaken in this project is novel. Bringing together the different dimensions and applying them to this particular question, the level of complexity. The papers have started to come out of the project, and they're being published in high-quality international journals, reflecting both the quality of the work and the novelty of the question that we're looking at. And there are more to come. And as Kevin Hume is highlighting, we look forward to seeing them. I think sometimes when people ask economists to come in, they expect the full answer to happen right there, and then we can move on and do the science. I think probably what we have in this project, given the complexity of the project, given the novelty of working together in different dimensions, is that we're probably more at the start rather than the end of the process. We've done a lot within the project, but there is a lot more to do to try to find the solutions, to identify the solutions. Of course, you can't wait for all the research to happen before you try to act. And it is an urgent question. I suppose if you were to summarize what we've established a methodological toolkit to look at these questions, all of which can be improved and refined. I want to acknowledge while Pat Murphy is here and Noel Meehan, Niall and other colleagues, the contribution of ASAP to this project. They've been enormously helpful. I just want to commend them on their openness. They've opened the lid on detailed processes, on data, and shared them with us. They've been trusting of us, and we really appreciated that. And we appreciated their knowledge and professionalism. They have a really fantastic handle of the issue, and it should be regarded as go-to people in trying to find solutions. Excellent systems, excellent data. So we really valued working with them. In terms of policy, we've heard that there's more that needs to be done in policy, but we must reflect on the changes that have happened over time. Policy has moved incrementally and improved, both in terms of its relevance and its focus, but operating at the scale that improving water quality requires to look at poses challenges for public policy. And as we move towards results-based schemes, maybe it's easier to focus on biodiversity. Certainly it's challenging to look at outcome-based water quality results-based programs, because everybody in the catchment and upstream contributes to the problem. It is difficult. Climate change probably has got a bigger focus in recent years, but that actually is an easier solution, given that all farms contribute in the same way to the problem. It all aggregates up. Whereas in water quality, their contribution very much depends upon what happens locally. In this project, we've worked with very many young researchers, junior researchers, up-and-coming researchers, PhDs and postdocs. And it's great to see their progress and development over the course of the project. And you've seen a number of them here, and wish the PhD students well in the vivas that will come up in the next year. In a few presentations, and the word trust has been mentioned. And trust is really important in terms of getting this to work. The things that impact water quality happen at a local level. To find the solutions we need to build trust with people to enable this to happen. And it is a tension in agri-environmental issues, the different perspectives and sometimes the language that is used. And in the RDS, we're developing a new strategy, building upon our experience of the Climate-Smart Agriculture Programme. And we're talking about trying to find common ground, trying to help build trust, not just with farmers, but between different actors and groups to help us to find solutions, to build trust. And I think this type of work, this type of event really aligns with the long-term historical focus of the RDS. The RDS is nearly 300 years old. It's 300 years old in 2031, which is to find solutions to important national problems, but grounded in good evidence, good science, and knowledge. So to wrap up, I just wanted to acknowledge one person in particular, Professor Mary Ryan, who not just coordinated this event, and it has been seamless, and it's been a very nice, coherent narrative between the different presentations, and there's a huge amount of work behind the scenes in making things hopefully seem smooth on the other side, but also more widely, the challenges of coordinating a project involving different disciplines. And to some extent, Mary has been the translator, given her background in science, in economics, and in extension, in translating what we mean to each other, to try to bring this project, and which was a hugely ambitious project, to a successful conclusion. So just to thank Mary, and thank you all for participating in the event today. Thank you.